Hey everybody. This could be the final video of the year. So this last video, possibly, we'll have to see how long each of these take, but it's just on density and population density. So if you've taken chemistry or anything like that, you've probably already heard of density. So this might be just like a quick review for you. But I had such a great year with you guys. I know it was cut short, but I really hope that you guys aren't strangers and you still stop by next year so that I can see you guys. Or yeah, I'm sad that this year ended like this, but you know, you guys push through. You guys are true warriors. Keep plugging away. You guys are doing awesome. Okay. So let's get to page 18. So think about certain items that have the same shape but are made of something entirely different, like a sponge and a brick, for example. If they were the exact same size, meaning the same volume, and you put them both in water, what would happen? Okay, so the sponge would, the sponge floats. And then the brick sinks. And that's because they have different densities. So what we will be dealing with today is density, which depends on the volume and mass of an object. The formula for this you will have to memorize, which this would have been if it was for the exam. So obviously you just have this right in front of you, but this is a very important formula. So D is density, M is mass, V is volume. You will almost always use this in any sort of volume problem with 3D shapes. Now, another thing that you have to keep in mind is we always have to check units. Okay, these types of problems, they might throw in a few that you'll have to convert the units. So make sure you're checking all of your units. So let's take a peek at what we have here. I'm going to be using my highlighter quite a bit. So a shipping container is in the shape of a right rectangular prism with a length of 12 feet, width of 8.5 feet, and a height of 4 feet. The container is completely filled with contents that weigh, on average, 0.25 pounds per cubic foot. Okay. What is the weight in pounds of the contents of the container? Okay, so let's see here. So we have the length, the width, and the height. So that'll help us find the volume. And then, so that takes care of V in here. Now, are we trying to find the mass or are we trying to find the density? Well, weight, which even though if you get into like physics and stuff, technically weight and mass mean something different, but in, I guess, these problems, Common Core said that they're the same. So what is the weight in pounds? So we are trying to find the mass, which means that this is the density. So the way that we know that this is density is because see how it has that division sign? It will always have a per something cubic. So something and then cubic, or cubic something, I should say, cubic something, per cubic something in after the number. Okay, so that is D. So let's first, so we are going to be using density equals mass over volume. We have the density, and this is pounds per cubic foot. Okay, so 0.25 pounds We need it in pounds. Okay, so that's good. And then cubic foot, feet, feet, feet. Okay, so that's good. So all of the units check out. Okay, pounds for the mass, cubic feet, all of 3 of those should be in feet. Okay, we're trying to find the mass, which means we need to find the volume first. So for a rectangular prism, it's big B times H. So really in this case, the big B is just length times width. So it's 12 times 8.5 times 4. So we get 408. So over 408. Put this over 1, cross multiply, bloop, bloop. And we're going to get the mass is, so 408 times 0.25 is 102. And like we said, we already checked out the unit, so pounds, and then all 3 of those were feet. So that's in the correct units. Cool. Let's look at this next one. A hemispherical tank is filled with water and has a diameter of 10 feet. If the water weighs 62.4 pounds per cubic foot, what is the total weight of the water in a full tank to the nearest pound? So the total weight to the nearest pound. Okay, well, let's see here. So pounds, we want it in pounds, so that checks out. Cubic foot, we have feet, so that checks out. Okay, so a hemispherical tank is half of a sphere, so it's like a little bowl here. That is a terrible bowl. Oh my gosh. Let's try this again. Okay, that's a little better. I should probably never do pottery. So the diameter is 10 feet. So diameter is edge to edge. We are, since it's pounds per cubic foot, we are going to be using density equals mass over volume. So the density is 62.4. We're trying to find the mass, and we need to find the volume of the hemisphere. Now the volume of a sphere is 4/3 pi r cubed. So for a hemisphere is half of a sphere. So we're going to divide this all by 2. So now it's just a plug and chug, 4/3 pi times, now the radius is not 10, that's the diameter. The radius is half of that. All over 2, so plug that all in. This is going to be kind of a hot mess express, but that's okay. Four thirds pi times 5 cubed, all over 2. Okay, so it's 261.799. That's an approximation. So that's what I'm going to put there. Okay, and then you just cross multiply. Bloop, bloop. You get M equals, now hopefully you kept that in the calculator because then you could just multiply it by 62.4. And 16336.3. To the nearest pound means the nearest whole number. So I'm going to underline 6. Look to the right. It's less than 5. So the final answer is 16336 to the nearest pound. Nice. Okay, so now, sorry, example number 3. Seawater contains approximately 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth would contain 1 pound of salt? Okay, so let's look at this here. So this is actually the density. Okay, so the density is here because it's got the per. And even though it's not cubic something, that's still a volume. Ounces and gallons and stuff like that, those all can be measurements of volume. So not ounces, liters. Liters can also be measurement of volume. Okay, so not per cubic something, it would be per liter because that measures volume. Sorry. So then 1 pound of salt would actually be the mass. Okay, and then we want gallons and gallons. Okay, so here's the issue here. So we have a pound of salt, but this is ounces per liter. Okay, so I am going to have to convert the pounds to ounces. So for my mass, it's 1 pound. So to convert it to ounces, we can go to our reference sheet. And 1 pound is 16 ounces. So that was nice and easy. Okay, so this just equals 16 ounces. Okay, that's a check there. But now liters and gallons, we're going to have to convert at the very end of all this. So let's set up our formula. Mass over volume. So the density is 1.2. The mass is 16 over the volume. Cross multiply. This one's going to take a little bit more to solve, but that's okay. So we get 1.2V equals 16 divided by 1.2. Is 13.3 repeating. Okay, so the volume is 13.3 repeating, but remember, the volume in this case was in liters. So this is in liters, and that's just from our density. So it was ounces per liter. So the liters is the volume. The ounces would be the mass because density equals mass over volume. Okay, we want it in gallons. Okay, so let's look here and let's look to see if there's a liters to gallons sort of thing. Yeah, so 1 gallon equals 3.785 liters. So, ooh, hi. So 1 gallon equals 3.785. Yep, 3.785 3.5 liters. So I'm going to take this and multiply it by 1 gallon over 3.785 liters so that the liters can cancel out. And then I'm just doing this number times 1 divided by 3.785. We get 3.52268. Okay, which to the nearest tenth of a gallon, so I'm going to underline the tenths position, look to the right, that would stay the same, so it would be 3.5 gallons. Now I have all of my units checked off, and I'm good to go. Cool. So actually, I guess this will be the second to last video. We're going to do I just don't want it to be too long, so we're going to do the population density in the next video. That shouldn't be too long either. Okay, so here we go. I'll see you in the next video. Bye.